This is an update to my ongoing IDEX tinkering. If you hadn't seen my previous videos, this was a Voron 1.8 that I had converted to IDEX, and then I did a Trident conversion on the Z-axis, and now it is a full Trident. So all the parts on here now are Trident, aside from the stretched frame. We're dealing with everything Trident as a reference, so hopefully things I do from here on out will be more applicable to people who are building Tridents now or already have a Trident and it's big enough they're considering going to IDEX. In my previous video I said I wanted to eliminate the umbilicals. That's done. I wanted to print some skirts and move the electronics underneath. That's done, so we don't have anything hanging off the back anymore. I had this little LCD in the parts bin. It's not even RGB, it's just white. Not the cleanest wiring job, but it's all in there. I'm waiting on some USB-C cables, because I didn't have enough. And with the Trident, I don't know whether it was with the revision 1, but somewhere along the line, they added these Wagyu connectors, which are awesome. I had stacks of spade connectors on these terminals before, and you really can't go past 3, and really more than 2 is too much. So happy to have those. And then when I get back to heated chamber tinkering, I've got the extra connections there to go with the extra solid state relay. But I also added an input for a secondary plug. The electric sometimes here will flicker. Very rarely does it go out for more than a second or two. So it's good to have a backup power supply. But the backup power supply has to be enough to handle everything, including the heated bed and a heated chamber if it has it. So I'm thinking, just as an experiment, I might run a separate power input for the bed and heated chamber, and then I'll only have to have a big enough backup power supply to power the 24 volt stuff. Also thought about adding some 24 volt caps in here, but I'm not really sure of the math on that or the cost. But that's something down the pipeline. Fans should be in tomorrow. I ordered an aluminum composite panel from Home Depot again. Last time I ordered black, and it was only black on one side. This time I ordered white, and it was a different brand when it came in, even though it was from the same company. It was a different brand, and it's white and has protective film on both sides. The other one only had protective film on the one side, and only the one side was black. So I guess it's pretty random what you're going to get when you order from there. This one was also 0.3 millimeter thickness on the aluminum. But yeah, happy to have something solid in the bottom now. I wanted to eliminate the umbilicals, and I've done that. So no more giant umbilicals sticking out 10 inches past the top. So we've got the normal cable chain path pretty much until it gets to the center. And then when it gets to the center, it ends, and then is split to each tool head. So, and they both have full range. And this little thing in the center I made just to make sure the wires stay below the level of this first cable chain here. Something more decorative could be made to accomplish the same thing. The orientation of the EBB 42s, the can setup. In my previous video I had the main connector sticking out this way. That ended up not working because it was going to hit the hot end. With both of them having CAN bus, it was going to hit the pins going to the hot end. The connector's coming out of there. So with it flipped toward the outside and that one flipped toward the outside, I think it's going to work out fine. When I ran the wiring to it, I had a 10 conductor 20 gauge ribbon cable, so I split it in half. So I ran 5 conductors to each tool head just so I would have an extra conductor in case something came up. Now I'm kind of regretting it because I got this extra wire hanging off here. Not sure what to do with it. Could be used for the sensor. While I'm here, one annoying thing when you're working on a printer and setting it up is that clipper will shut down because you don't have any thermistors installed. So if you take a 100 ohm resistor and stick it in a connector, you can stick it in the board to keep it happy, and clipper will stay running so you can experiment with it. And as long as you don't have a heater connected, I don't see what problem it could ever cause. So all the motion controls back up. These wires here are just going to the limit switches temporarily while I got the directions and homing and everything sorted. And I won't do the Z for now because there's no hot end there. So obviously the tool heads haven't been wired yet. Ran into a problem with the probe wire and this wire from the limit switch back here. The newer versions of the carriages have a slot for the wire to come out the side. The old ones have it coming out the center of the back, and I'm afraid of it rubbing up against this cable chain. So we got to redo the carriages. And then the question was, do I do stealth burner carriages? And I would like to. This is a stealth burner carriage here. I would like to, because I like the way the front parts attach better. With these old ones, you've got 2 long screws, real long screws, that got to be put through the back underneath the cable chain, and they're a pain. So it's good to see those were eliminated in favor of heat set inserts on these. But I'm not sure I can figure out a way to use the NEMA 17, and I've already got the square EBB 42 there and my nifty tool head PCB holder and cable chain anchor. So I think I'm just going to stick with the Trident Revision 1. Sticking with Clockwork 1 because of the motors and all that. So I don't know if I'll put stealth fronts on them or not. As Eddie mentioned, if you look at his GitHub workflow, part of it is clearancing stuff for the stealth burner tool heads. So I don't want to lose anything. But when I ordered new Omron limit switches from DigiKey, I threw in some NeoPixels, so it'd be pretty cool to get them wired up to the CAN boards and doing cool things. So there's not a direct connection for the Omron type probe to the EBB 42 CAN board. I do have 24 volt and ground there, and then could wire in a protection diode and wire it to one of the limit switches. But I think it might be better to go with the clicky probe, which I've put off messing with. I don't know why I want to hang on to the Omron probe. I had the crappy melty probes before, and just before I started messing with the IDEX stuff, the one on this printer went bad when it was a 1.8, and I got these Omron probes, and the consistency was so much higher, it blew my mind. So now I hate to give them up. And that's also why I'm switching from generic limit switches to the Omron switches. So I did order extra for the purpose of doing clicky probes. So I need to make a decision on that and make a decision on the rest of the tool head. The wide drive functions, but I'm pretty much not happy with any part of it. On the Trident, there's just not enough room here to work with to have anything other than an idler in the front. With the 1.8, when I had the room on top to work with, we squeezed an adjuster in there. And I could squeeze the adjuster down here. If I move the rails back up to where the 1.8 rails were, because when they switched from 1.8 to Trident, one of the things they did was lower the rails to give more room above the tool heads. Of course, they also moved the bottom rail down. But like I was saying, the wide drive pretty much sucks. It's just an L-shaped belt path. These XY joints, I just shaved a little off the bottom of here so there would be enough clearance. And then again, it's just shaped to fit the belt. And the two ends of the belt get inserted from opposite ends and then get tightened down. And I could not come up with a good idea for tensioning yet. I thought about maybe having an extra pulley squeeze in here, but that didn't really work out too well. So just to get the thing back together and running, I just put the motors on a plate and made these little plates. And then you just pull down on the motors until the belt feels tight and tighten it. There will be a better way to do that down the line somewhere, at least hopefully. And the other thing that sucks about these, I couldn't find a good way to print it, so I print it in halves and then acetone welded it together. But then this is held in by a single M3 bolt with a hammerhead on the back, and that's all there's room for. So you have to glue it together, install it in here, and then try and put your bolt through and get a shim on each side and the pulley in the middle, and then get the belt through. And all parts of that suck. And then on the back, you've actually got to remove one of the X motors to be able to get to those. So the ones holding it to the frame, I got to thinking we could switch to just plain M5 bolts that you could get an open-ended wrench on, and install them down here where it's easier to get to, and then slide it up and tighten it with an open-ended wrench. But the bolts holding the pulleys on, I'd like to find something better for that, because you have to screw it till it gets to here, put your pulleys on, run your belts, and then finish putting them in. But then if you have a problem with these belts, you're going to end up having to drop your other motors and your other belts, which sucks. So, like up here on the XY joint, these aren't actually going through this part. They just fit the cap of it. So if we get enough meat on the back side of these, maybe we would be able to do something like that from the front. Assuming those tops of those bolts aren't thicker than this width here, which I think it is. So I don't know. But yeah, none of that's ready for prime time. I think my cable chain path is ready for prime time. It will not work on a V2.4, but I think all this stuff about trying to keep things compatible between the Trident and 2.4, I mean, there are, what, 4 or 5 Voron models at this point, and the only two that share this gantry design are the Trident and 2.4. So why insist on things being compatible just between those two? I managed to set up the Big Tree Tech U2C just by going through the manual, and I may have referenced Eddie's original CAN bus video. I could not tell you how to do it or walk anybody else through it. but I got it to show up on the Pi, and I haven't done anything else to it since. For the EBB42s, I followed Eddie the Engineer's setup guide on YouTube. And the first thing it will have you do is install CAN boot on the Pi, and then from there you'll create CAN boot firmware to install on the EBB42s. That is important because when you update Clipper, you're going to have to update these. To update it over USB, you've got to press the boot and reset buttons, which are going to be on the other side of here. You can't get to them without removing the board. So I would have to remove this every time I wanted to update Clipper. And I got through it, and they're showing up now. And no, I can't guide you through how to do it because I barely made it through it myself. When I ordered the CAN bus stuff, I had no idea what I was ordering. So I knew I was going to have 2 tool heads. So when I decided which UTC board to order, I ordered the one that said it had, could handle multiple outputs. Well, it turns out that you don't need that. The 2 extra outputs it has are these 2 USB ports, which are actually CAN bus, but that's a little complicated and over my head. But they're separate from the main one. So you have all these outputs here, and these 2 are all CAN outputs, and they're all linked together as one. If you take a meter and go from here to wherever, they're all linked. As Eddie said in his video, the wiring for the big Tree Tech stuff is different than the Mellow stuff or the Huvud stuff. So, you can't use a cable you made for one on the other. And the documentation for the wiring is just atrocious. There's nothing out there. I think they're not selling nearly as many as they could had they made it simpler for people. I'd like to thank Knife, who responded to a comment in the other thread that mentioned CAN bus. His comment sent me on a path to educate myself a little more and get somewhat of an understanding. And then I asked some questions in the DoomCube Discord, and the same person responded and answered all my questions, and I have a little better understanding now. Wiring examples and things like that are what need to make it to the dumb end users like me who don't understand these protocols. So I'm going to pass on a little bit of what I learned, but I am not qualified to answer any questions. I gained just enough of an understanding to get this stuff working. So this is your bus. Thinking just your wiring, but we're calling it the bus. Think in terms of bus bar, the bus bars in your electrical panel at home, kind of. It's just 2 strips that you could tap into anywhere along the line to make other stuff work. And one of the rules of this bus is that both ends have to be connected by a 120 ohm resistor with no other resistors in between, so just beginning and end. So since I'd like to have used my original devices, but I'm not taking them back out of the printer. So since these devices have a jumper for that resistor built in, then we don't actually need the resistor. We just need to set that jumper, and each end has to have a device. It doesn't matter which device. So if you just have one CAN bus set up, or one tool head set up, it's easy. You've got the U2C on one end with the jumper on the 120 ohm resistor, and you've got your tool head board on the other end with the jumper on the resistor, and all is well. So say you want an IDEX, well, you can just jump off these wires to another tool head board without the jumper on the resistor, and this is called the stub, where it comes off. And the other rule is that this distance cannot be very far, like less than a foot. So ideally, you could have wires coming from the U2C and then just double up, both sides of this wire into that connector when you crimp that connector. Same for the other. CAN high and CAN low. And all devices will be happy. And it doesn't matter where they're located, as long as they're not too far from the main bus line. So the way mine is currently wired, which I wired before I knew what I was doing, I've got the UTC in the middle with no jumper on the resistor, and then I've got both tool head boards on the ends with the resistor. In theory, that's what it looked like, even though these wires are running in parallel. One other thing to add: you've got 120 ohm resistor at each end. You should always be able to measure 60 ohm between CAN high and low, regardless of how many things are installed, regardless of how it's set up. If it's reading 120 ohm, you probably don't have a 120 ohm resistor at one of the ends. You can just test on the back of the connector. These top two here are CAN high and CAN low, and if that doesn't read or close to 60 ohms with the power off, something isn't set up right. So that's the type of explanation I'm looking for as a 3D printer enthusiast. I don't need to know the electrical engineering reason behind why there's a 120 ohm resistor on each end. I've gone into that. Do not need to know why this is CAN high and that's CAN low. Just need to know how to wire stuff. Wiring diagrams like are available for the MCUs on the Voron pages. Those would be awesome for CAN bus. So if someone else who understands this stuff better wants to make a similar video, more thorough, and they would actually know what they're talking about, I encourage that.